Every AI chip on Earth depends on a single machine, built by a single company in a town of 45,000 people in the Netherlands. There are only about 400 of these machines in existence, and right now 3 separate forces are racing to either control them, replicate them, or make them irrelevant. The machine is called an EUV lithography system, built by ASML in Veldhoven, Netherlands. It weighs 180 tons. It contains over 100,000 components from 5,100 suppliers across 15 countries. It fires a laser at molten tin droplets 50,000 times per second, creating plasma hotter than the surface of the sun, then bounces that light off mirrors polished to 1/1,000,000th of a meter flatness, the smoothest objects humans have ever made, to print transistors smaller than a virus onto purified sand. Each machine costs up to $350 million. It takes 20 trucks and 3 cargo planes just to deliver one. And it took 25 years and over 10 billion euros to develop. ASML ships roughly 50 to 60 of these machines per year. Every single one is already allocated years in advance. TSMC, Samsung, Intel, all booked. There is no second source. If Zeiss, the German company that makes the mirrors, has a bad quarter, global chip production slows down. One company. One supply chain. One point of failure for the entire technology industry. On March 21st, Elon Musk announced Terafab, a $25 billion joint venture between Tesla, SpaceX, and xAI to build chips in-house. The headline goal is 1 million wafer starts per month. That would require more EUV machines than currently exist on Earth. But the real play isn't volume lithography. It's iteration speed and advanced packaging. By owning the mask shop and packaging line, Tesla could compress chip design cycles from months per iteration to weeks, potentially 5 to 10 times faster than competitors relying on external foundries. And by using a chiplet architecture, only the compute cores need expensive 2-nanometer EUV. Memory and I/O chips can use older, cheaper equipment that's readily available. Meanwhile, China is running its own Manhattan Project for chip independence. Huawei is coordinating thousands of engineers across state research institutes to build a domestic EUV machine. Their prototype is operational in Shenzhen, generating about 100 watts of EUV power. Production machines need 600 or more. China's top semiconductor executives openly admit they match ASML's 2008-era technology 17 years behind. Realistic production timeline: 2030 at the earliest. But with TSMC sitting in Taiwan, the geopolitical math changes overnight if China makes a move. And then there's the wild card. A Norwegian startup called Lithography just raised $40 million, backed by Microsoft, to develop helium atom beam lithography. Their beam is 0.1 nanometers wide, 135 times narrower than ASML's light. If it works, it could print chips 10 times smaller than anything possible today. They're targeting a pilot tool by 2029. It's early stage, but it's the first credible attempt to make EUV lithography itself obsolete. So the entire AI revolution, every self-driving car, every humanoid robot, every GPU training the next frontier model, traces back to tin droplets, lasers, and mirrors in a small Dutch town. Musk is trying to work around the bottleneck. China is trying to replicate it. And a 30-person startup in Norway is trying to leapfrog it entirely. The race to control the machine that makes all other machines is the most important technology story nobody is paying attention to.